Hello, this is Dr. Divya Pradhan, and today we are going to talk about the atomic structure. Okay? Well, first, what is an atom? The atom is the smallest part of an element that displays the properties of an element. So, in other words, you don't have to take a big piece of the element to know the properties. All you have to do is study the atom. The atom is made up of subatomic particles, the proton, neutron, and electron. And science has advanced so much that now we know that these subatomic particles are further made up of subatomic particles. But again, that is beyond the range of this class, okay? So we'll stick to proton, neutron, and electron. Proton has a positive charge, and it has the AMU, atomic mass unit of 1. Location is the nucleus. Neutron has a 0 electric charge and an AMU of 1. Location is again the nucleus. Electron has an electric charge of -1, but the weight is so small, the mass is so small that the AMU is considered 0 and the location is electron shell. Let me explain what electron shell is. If we see the helium, so here the atom of the helium, you can see the central cluster of the proton and the neutron, right? Here is the proton, here is the neutron, and around this, orbiting the nucleus, are the electrons in what is called the valence, the electron shell or electron cloud. All right. So approximately here we can see the location of the electron. All right. Now, whenever we write an element, we always write it as an atomic symbol. So instead of writing, say, for example, carbon, we just write C. Instead of writing sodium, we write Na. All right. Iron, we write Fe. So whenever we write an atomic symbol, we also must know its mass number. What's mass number? Protons and neutrons. Obvious reasons. Electron has an AMU of 0. Atomic number is the number of protons in a nucleus. So we'll talk about the importance of the atomic number. This is going to decide the characteristics of the element. All right. All right. So now let's see. Now here, what we have seen is even though each element consists of a different atom. Yeah, we know that. But the certain chemical and physical properties reoccur. That means they are periodical. They reoccur after a certain interval. And it depends on how you've arranged it. So what happened was, one of the scientists, you don't need to know his name, he arranged the elements, known elements, according to their increasing atomic number. What is atomic number? Atomic number is the number of what? Protons, and therefore the number of electrons. I'll talk about that, okay? And when he arranged it in the form of periodic table, he realized that each characteristic is reoccurring periodically. The periodic table, you will have something called groups and periods. So what's a group? Groups are the vertical column. All right? And what is a period? A period is a horizontal row. Okay? All right. So now let's see. So here's a periodic table. Remember what we talked about? If you remember, we talked about groups and we talked about periods, right? So here is a group and here would be a period. Yeah, we understand this. All right. So like I said, the elements are arranged in the order of the atomic number, increasing atomic number. It starts with hydrogen, helium, and of course lithium, beryllium, boron, carbon, nitrogen, etc. All right. So the first 4, of course, are very, very important, and the first 4 periods contain the elements that are most important in biology. But of course, nevertheless, all the other elements are also important, right? Now, we'll come across a word called isotope. 2 parts. Iso, same. Topos means place. Why? Because isotopes are atoms. They are the same atoms of the same element. Carbon, carbon, carbon. Same atomic number. That means number of protons. 666. but because of difference in neutrons, they have a different mass number. All right. And so isotopes means that these elements of different mass number will occupy the same place. Topos means place in the periodic table. Just because they have a different mass, that will not change the property as such. Carbon will remain carbon, except that if you are going to make the nucleus very, very heavy, it's going to become very unstable. And when it becomes unstable, then guess what? It becomes radioactive. It will have radioactive decay, it will start breaking down, and it will start releasing radiations. All right. So here we use low-level radiations with the help of isotopes, and what we do is we use this for scanning. So this is a scan of the thyroid gland, and it's a PET scan actually, and it reveals which portions of the thyroid are active. So yellow and red are active, and the white part that you can see is indicating, of course, the presence of a tumor right here. Okay. High level of radiations are also used to kill bacteria and fungi. And so what happens is, if there are irradiated peaches, these spoil less quickly. As you can see, this is spoiled, this is unspoiled. And a lot of physicians use radiations also to kill cancer cells. All right. So here is the person getting radiation in the brain for tumor in the brain. All right, let's talk about electrons. So the electrons, these are, of course, like I said, in an atom. Atom is neutral. It has no charge. Okay, because why? The number of protons. By the way, this is how we write protons, is equal to the number of electrons. All right, this is how we write protons and electrons in a short form. Neutrons is written like this. So in an atom, the number of protons is equal to number of electrons. So if the protons are 7, electron will also be 7. All right. The electrons, therefore, if I say the atomic number, like for example, carbon is 6, therefore that means number of protons is equal to 6. Yes. And number of electrons will also equal to what? 6. Now these electrons are arranged in shells around the nucleus. And here these are also called shells or orbitals. And we follow the arrangement, we follow what is called the octet rule. Spelling is misspelled. Rule, R-U-L-E. Okay. All right. So here let's look for hydrogen. In hydrogen, look at the electronic shell. The hydrogen has one proton, and therefore it has one what? Electron. Because it has one proton, one electron, so one electron is in the first shell. All right. Carbon has 6 protons, therefore it has 6 electrons. So how are we going to arrange these electrons? The first shell always has only 2, can only allow 2 electrons. The second shell now can allow 8 electrons. Remember I told you the octet rule? So what is the octet? Octet means 8. So here every shell can hold only 8 electrons, not more than 8, except the first one. The first one can hold only how many? 2 electrons. All right. So now let's look at nitrogen. Nitrogen, look at the atomic number, which is 7. So therefore number of protons is 7, electrons is 7. First shell 2, and the second shell will get how many? Will get 5. All right. So here oxygen 16 and 8, mass number 16, atomic number 8, and therefore the number of electrons is how many? 8. So first shell gets 2, second shell will get the remaining 1, 2, 3, 4, 5, 6. And last but not the least, phosphorus has the mass number 31 and the atomic number 15. Therefore electrons are 15. First shell gets 2, second shell gets 8. Spillover 1, 2, 3, 4, 5 is in the last shell, which is also called the valence electrons. These are called the valence electrons because this will define the valency. We'll talk about that later of the atom. All right. So the outermost shell, the electrons in the outermost shell are called the valence electrons. All right. Sulfur has atomic number of 16, and therefore number of electrons is also 16, right? So first shell 2, second shell 8, third shell will get how many? 1, 2, 3, 4, 5, 6. All right. So I think with this we come to end of our presentation. If there are any questions or concerns, please stop by my office. Well, thank you for your attention and time.